We're going to take a look at the TetraSentry demo. This is a simulation running in the TSx programming environment in simulation mode. What you see here are the 4 valves of the TetraSentry, 2 on the right in series and 2 on the left in series. So right now the trip header pressure is at 7. We pretty much have similar pressure throughout the system. We're in a trip state, so red is tripped. The trip header brings oil in the bottom and it drains out the top. The orientation is such that the oil moves upwards through the block to keep air from accumulating and causing a problem during testing. If we activate all of these valves, we'll see that the trip header pressure comes up when the valves close. What you see is trip header pressure of about 160. The pressure at the cavities between the serial pairs of valves runs about half of the trip header pressure. That's because as the oil passes up into the block, it goes through a pair of serially connected orifices that pass through the inner valve cavity. So these 2 orifices are the same size, which will result in a pressure between the orifices of approximately half of the overall pressure across both of the orifices. That keeps pressure between the 2 valves in the serial pair to allow us to diagnose any problems with the downstream valve. In a situation where you put 2 valves in series, you never know if the second valve is going to hold the pressure if the first valve is closed and not leaking. So you wouldn't know if S2 can hold the pressure if S1 is fully sealed until SV1 opens. So let's look at what that does to these pressure gauges. We'll de-energize SV2 and you'll see the pressure gauge between the valves drop to a low value. That's because now the valve is open and bleeding all of the oil that comes through the first orifice directly to drain. We re-energize that valve and see the pressure come up. If we de-energize the upstream valve, you see the pressure go high, near approximately the same as the trip header pressure. And that's because now we're short-circuiting the first orifice and all the pressure drops being taken by the second orifice. Once again we close it. So let's go through a valve test. If there are no failure indications in the system, the operator can click Test All and start the test. And if you watch the annunciators on the left side of the screen, it'll tell you each step that's happening when each valve is energized or de-energized and what the expected result will be during the test. At the same time, over on the right side of the screen, you'll see the error messages. So for instance, right now, if SV2 opens, you get a warning from the alarm system that PT01, which is the transmitter on the right, is reading low, and that's interpreted as, well, we also have information from the system that SV2 has been de-energized. So we'll re-energize that and start the test. If you notice, when I pushed SV2 or de-energized it, the start button turned gray. We don't allow running the test if there's a failure present. So we start the test, it de-energizes SV2, verifies that we hit low pressure on PT01. Now we energize SV2 and verify that pressure comes back up. Likewise, we de-energize SV1, watch for a high pressure, energize it again, and watch the pressure come back to normal. So the right side is passed, we're jumping over and doing the same thing on the left side of the block. So we'll go through each sequence step, getting feedback of what's happening and if it's working fine, until we finally get to the end and the test is over. So that's a complete test. We can also do a test just on one side. So if we start here, it'll run a test just on the right side, and that's something you might use if you were getting ready to do some maintenance on the left side. You'd want to test the right side first to verify that it's in suitable working order for tripping the turbine before you isolate the left side for service. So that's a demonstration of testing the TetraSentry using the TSx Turbine Safety System.